WarsawJS.
Hello, everyone. My name is Piotr Szlachciak, and I'm here today to talk to you about APIs and how to consume them so that they taste best. And if my voice sounds a little bit weird, it's because I have been sick for the past few days. Now I'm fine, but my voice is not. Anyway, I've decided to give you the big takeaway of the entire presentation at the very start. So here's the first slide. And I'm going to tell you what it's there because you probably can't see. The first line says get the user input, then create the URL, then fetch the URL, get the data, get the price from the data, and set the price. Can anybody tell me what's wrong with the code? Thank you so much. But actually, the biggest takeaway from the entire presentation is that there is something wrong with this code. Okay. In my opinion, this code mixes abstractions, mixes interacting in the UI with fetching the data. And the biggest takeaway is that we should always abstract fetching the data so that from the other parts of the code, it's the easiest that it can be. So just a function call, right? This code is even more perfect than the previous one because we just get the ID, we fetch it, and then we display it. Nothing more, nothing less. And the rest of the talk is just going to be more of my opinions on how to best abstract it. Opinion number one, instead of just abstracting the entire code into a function, you should actually wrap it in a class. And you might think JavaScript and classes, what are you even thinking? This isn't like, 1995 where we have to write Java. It's 2022 current year argument. We don't have to write classes. We have beautiful functions. Why classes? Because those guys that actually wrote Java in 1995 figured something out that with classes, testing is nicer. So the only reason I'm using classes here is because I want my code to be easily testable. And so once I have this class and I implement the method, okay, so this is really simple. The blue code here is the exact same code that I had on slide 1, just wrapped into a class. So, more code, but it's going to be more fun because now I can do this. I can say that instead of calling fetch from the global object, I have a constructor that takes fetch. And then I use the fetch from the class's properties. Okay, so if you've never seen code like this before, then my personal opinion is that you should start writing code like this because, and this is the best part, if you want to use this code in the application section of your code, in the source code, then you just provide the normal fetch. In tests, however, I hope this is the test, right? In tests, however, instead of creating the class with a normal fetch function, you create a fetch function of your own. And what do you say there? Well, I expect that the URL is going to be something that I actually know. And then you can return whatever data that you actually want. If you cannot see, the code is really simple. It just says fetch is this function that checks the URL and returns this data. And then later, we create the class with this fake fetch function. We call the class's function, and then we expect the output to be correct. But this simple test actually gives us all the tools we need to then later test more complex interactions. Because here it's actually a pretty simple example. We just have a service that returns some data about a cryptocurrency, in this case, Bitcoin. And it returns not only the price, but we're only interested about the price. So we check that the URL is correct, and then we check that given this data structure, we just take away the price. So this is simple, but you could imagine that actually the output might be in a complex format, or the parameters that we are passing need to be specific, like we need to pass a specific token or something. And the test is a great place to actually check that the logic that we have is correct. So instead of just writing all of this logic in one place or having it in a function, which can be hard to test, we put it into a class, we call it just like the function, but with a dot, and we have all the functionality tested. Next thing, you're writing JavaScript, but you shouldn't. You should write TypeScript. So, and this is, of course, another opinion, but my opinions are the best because they're mine. And I think TypeScript is better than JavaScript because it provides you with more safety and more productivity. So everything that you want and everything that you need. With more productivity, because then you can just say that I know what is the type of the variable, and then you know the entire data structure that your API returns. And then more safety, because you're not going to access any properties that aren't there. But actually, there's a problem. Because, if you're just writing code like this, and for those of you in the back that don't see, we have an interface. We call response JSON on the fetch response, which just parses it as JSON, and then we cast it. We say, this thing is actually with this type, with the type of this interface. The problem is that there is no safety there. We just assert something baselessly. Like, like me saying that, I don't know, the price of Bitcoin is 40,000. I don't know, I haven't checked. It might be, it might not be. There is no assert. It's just baseless claims. So what we actually can do is verify the data in runtime. So I can recommend this nice library called Zod, but there are others, and you can use any of them. Basically, the idea of the library is to take the types part of TypeScript and make it also work in runtime. So if you have some data and you want to assert the type of the data, right, you can specify a schema. It looks very much like the interface from before. Instead of just saying interface, we say Z object. But, syntax is never really something important. So you just say Z object, and then Z object, Z number. And then if you want to get the TypeScript type, we do Z in first. So basically, if you want to do anything, you just do Z dot, and then you find what you need. And with this small piece of code, we have declared the same interface as from before, but now we can actually use it in runtime. So in the code that we had, after we parse the data from JSON to a JavaScript object, we call the coinsResponse.parse, which does two things. First off, it does the TypeScript magic, which is asserts that the type is correct. But second of all, it does the JavaScript magic in runtime, which is goes through all of the data and checks that the types actually match. In this way, you get the safety and the productivity, and you don't have to worry because there is the same exact amount of code, but now it's even safer. So great. So now, summing up, we have an abstraction. We can test it. It's super safe. Or is it? Or is it we have forgotten about something? We have forgotten. Oh, no, actually, you know what? I can't even remember my own slides. Instead of doing the next thing, which is error handling, I'm still going to ramble about types. When it comes to types in TypeScript, you have all of the basic ones, like an interface which is an object with some properties. You could have a string, a number, all of those. But when it comes to your application, you don't actually think about types in this way, right? Instead of strings, numbers, or objects, you have users or user IDs or some emails, right? And it would be great if you could enforce some of the constraints on those types also in your application. So instead of saying that the email that you're passing to the function is a string, you could say that the email is actually an email. Just like you say that the user is an object of type user, you could say that the email is a string of type email. So TypeScript by default kind of does not support this idea. It's called nominal typing. And there is a nice hack, which I'm going to show you. The hack is this. You create an interface, you extend a string, and you add some random property, okay? So the property name and the property value don't really make a difference. For consistency, I'm naming the interface, when the interface is named CoinID, I'm naming it CoinID brand, because branded types is another name for this thing. Once I have this interface, right, I create a function also named CoinID. So the interface is named CoinID, the function is named CoinID. And the function kind of works like a constructor for the type, but it also enforces runtime constraints. So here you have the CoinID, and it has a regular expression, which checks that it's actually a valid CoinID. If it's not, it throws an error, right? And then you can create an instance, but it's still going to be a string, right? It's only in terms of what TypeScript thinks. You can create an instance of this CoinID by just calling a function with a string, and then you get a value which is of type CoinID. And the best thing is, even though at runtime it's a string, in TypeScript you cannot assign a CoinID to a string, and you cannot assign a string to a CoinID. So once you have a value that's a CoinID, or it could be an email or whatever in your system, right? You get a type safety for this value. So we can add another layer of safety, another layer of types. So in the getPrice function in our class, instead of accepting a CoinID, which is a string, we accept a CoinID, which is, of course, a CoinID. And now, hopefully, to the part that I wanted to talk about, which is error handling, right? Because what's the point of adding all of this safety if we're just going to say, OK, the API returned 400, I don't care. I don't care. I'm just going to parse it anyway. No, we need to check that our API returned a correct status, right? If it's not 200, we want to say no. So the API returns something else than 200, we throw an error. And OK, what happens if we parse and it's not what we want? Well, we should also throw an error. So we check the result of the parsing, we throw an error, we check the response, we throw an error. And one thing that I would like to for you to remember about error handling is that once you have a class, once you have your own function, once you have your own thing, you can also add your own class for the error. And it's you're probably thinking, oh my God, this guy just won't shut up about classes. Yeah, I don't like them too, but they're useful. They're useful. If you create your own error class, what you can do later is once you catch an error, right, you can check if it's an instance of that error. And then you can handle those code paths separately instead of trying to match by the error strings. So it's actually useful. So we had type safety, we had an extracted class, we have custom errors. What do we have next? A puzzle for you guys. The code here says const coins is an array of Bitcoin, Ethereum, and 200 more coins, right? A huge array of coins. And then the variable prices is set to promise all of coins mapped to the request to the class to get the price, right? So we do all of the requests, we do promise all, we get the prices. What's wrong with the code? All settled? No, I mean, yes, you could, but it's not what's wrong with the code. I mean, that's an improvement, but it still would fail in the same way. Okay, my next slide. This is not the next slide. Come on, this is the next slide. If you're gonna do a lot of requests and you're using an API that's, let's say, properly implemented, you're gonna get an error. Why? Because they rate limited you, right? You haven't paid them enough. You haven't paid them enough, so you need to stop calling them so often. And You're the poor developer. You're just wanting to call a function and it returns an error. Why? Because someone else, somewhere else in the code called the function 200 million times, and now the API returns an error. You cannot do anything. But maybe, because you now have a class and you now have an abstraction, maybe you can solve it somehow. How to solve it? And so I'm just going to tell you the solution. Not going to walk through the code. If the code was bigger, this would make sense if you could see the code. But the solution is to add another class. The solution is a rate limiter class. And the rate limiter class has one thing to do: queue the requests. Instead of just calling all of the API, instead of making all of the API calls at once, you queue them. You wait for a period of time that's acceptable for the API. And then once the period of time elapsed, you take the first item from the queue and make the request. So from the point of view of the API caller, you just have the same one line of code: CoinGecko service get price. You don't worry about it. But inside of the class, right, you have this. Wait, is this? Yeah, here. You create an instance of the rate limiter, and before you make a fetch call, you just call the rate limiter first. And because of this, you will not run into rate limiting from the API. Now, rate limiter inside the class also works wonders. And this is also why you should have a class instead of a function if you have multiple different requests to the same API, because they're going to rate limit you on all of those requests. And you want to reuse the rate limiter instance for all of those requests. So if you, from the same service, you want to fetch the price, but you also want to fetch, I don't know, the newest exchange data or some market participants or whatever, those are different APIs. They come from the same service, so you want to reuse the rate limiter for all of those requests. And if you also have a class and you have multiple requests, you're surely going to find out very soon that the logic for making those requests for a particular service is actually very similar, right? For different services, it can be very different. You could have different cookies, different API tokens, different statuses that are returned. But for the same service between different endpoints, it's probably going to be very, very similar. So you should extract a method inside the class, and then all of the requests to the service are going to be very easy. And all of them are going to have the safety of the types. All of them are going to have the safety of not being subject to being rate limited. And you're good. And now, is this the last thing? It's almost the last thing. It's the second to last thing. Second to last thing is, did you know that you can actually abort a fetch request, right? So you're making a request. You find out that you no longer need it. For example, you might want to have a timeout, right? The default timeout for fetch requests is like infinity, right? You don't want your users to wait. You just want to display, no, something went wrong, sorry. To do that, you should abort the request. And in order to abort the request, you can use another class. But this one, it's built in. It's built in. It's an abort controller. And the abort controller has a beautiful method called abort that you can call. And then in order to actually use it, you get the signal from the abort controller. You pass the signal to fetch as a parameter. And then you just call abort controller abort inside a timeout, for example. And you're good. You're good. You're not making a request anymore. And your users are happy. You are happy. Everybody's happy. Last thing. You've done all this. You have timeouts. You have rate limiting. You have great types. You have everything, right? You push the code to production and it breaks. It will break, right? Because you're interacting with some random API service that you just found on the internet. It just won't work. But because you've built all of this infrastructure, you're now in the best position that you could be. Because with solid types, with solid tests, you could take what the API has just returned, build a test that does exactly that, because you can mock the fetch function, so you can exactly say, oh, the API actually returned the correct response, but with a 400, so I should actually treat it as an edge case. Check this in tests, have all of this figured out, and still in the code that actually needs the price that we're all about, you just have one line: CoinGecko service get price. Is this all? Thank you very much.
Wow. Just in time. Just in time. I was about to ring the gong over here. Do you know about the gong?
Oh.
Yeah, I was just getting ready to ring the gong. We have a gong over here in case your talk goes more than 30 minutes. You knew that, though.
Do I go to jail, though?
Yes. Yes. We have time for a couple of questions, though, if anyone has any questions for Mr. Szlachciak.
Yes.
Anyone have any questions? I'm coming. Here you go.
Thanks for the talk. I have a question. How do you handle rate limiting with horizontal scalability?
Okay, can you expand a bit on this? With horizontal scalability, you mean that there are different...
I mean, if you have multiple servers running and your users, if we're talking about consumer application, if your users are connecting to multiple servers, they can't communicate through this single class. They have to have some kind of caching service or something.
Yes, so if I understand the problem correctly, because you're calling different servers and each of them has their own rate limit, you can run into different rate limits, right? Or
if multiple users are calling to, usually it's a load. Usually there is a load balancer that distributes the load between several servers, if we are talking about horizontal scalability, right? And your servers are usually not talking to each other in the real time. They can use a database, but writing in a regular database would be, would take a lot of time. So how do you handle rate limiting if you have 2, 3, 5, 20 servers?
But so I'm very sorry, because I think I'm still not understanding the question. But the way I was talking about rate limiting is in a scenario where you are calling another server from a server or from a client, and this server is rate limiting you, right?
Right. So, look, I'm just saying that just having a class that limits the rate of the calls wouldn't be enough if you have more than one server in your network. Means horizontal scalability is basically when you are creating multiple servers to handle the workload.
Yes, but so the rate limiting from the point of this class is only to avoid being rate limited by the final server that actually does the rate limiting.
And if you have 2 of these classes on 2 servers, they are doing their rate limit is twice more. So they will be doing twice more the number of requests to the same endpoint, and they'll hit the rate limit.
Oh, so no, okay. So I think I get it now, right? You have one service that does the rate limiting, but you have multiple clients, and each of them think the rate limit is 100 per second, and each of them actually run into the rate limit, right? Okay, I think I get it. So the solution would just be to set a different rate limits for the clients, right? So because I know it's not a perfect solution, right? So, but in this example, I was thinking of a case where you're rate limited per instance, right? In your example, you would be rate limited there would be a global rate limit, right? And I was thinking of a rate limit per user. So this won't work for a global rate limit.
Next question.
One more question. Do you know Swagger CodeGen or Open API Spec CodeGen, and how does it compare? And second question, how would you implement? Do you have any experience with implementing token refreshing?
Okay, so actually, my experience with token refreshing is the same, or from the same project that I used, Swagger CodeGen. And when it comes to, I'm going to do CodeGen first. What I personally found is that even though it's actually a bit more work in terms of what the developer has to do, and then in order to maintain sync between all of the two versions, it's worthwhile to not have all of your API calling code auto-generated, because what you'll find in most projects is that the contracts are actually violated a lot because of different errors, because of different return types, because of actually returning different data in the contract. And if you're implementing an API client that's auto-generated and it doesn't match, then you would have to change the auto-generated code, which is bad, because then the generated code would overwrite your changes. So this is why I actually prefer to write a lot of the API calling code by hand. And with the token refreshing, so when I did this project, we actually used RX for this, and I wouldn't recommend it because the code was a mess in the end. I think what I would do now is I would do a similar thing that I did with the rate limiter, which is I would just have a property of this class be another class that just passes the request through itself and checks whether or not the token needs to be refreshed before making the request. So just a simpler solution.
Thank you very much.
Thank
I think
you
it was
very much.
fantastic. If you have any more questions, of course, you're going to be around, right, for the pizza. So you can ask
Yes.
more questions later. Let's have another hand, please, for Mr. Nice job, nice job, nice job.